Okay, so we're talking about the communication test, and here is a problem, and I want you to communicate to me by writing it on a piece of paper. Anything you know about this parabola. From just looking at the numbers, you could tell me several things. Give me one thing. It's upside down. How do you know that? Because of the negative. Good. All right. And technically, this really only tells me one side. Which side? The right side or the left side? Technically, only tells me that the right side is going up. The thing that makes me logically know that the other side also has to be going up is that it is a parabola. Oh, sorry. Down, down. The negative means it's going down. Sorry. And it's on the right. It's going down. This part is the part that tells me whether or not the left side will be the same or different. And when it's an even degree, anything with an even degree, they always act the same. So this must be going down on the left side also. Could it be going like that? No, because what part do you know that I would have messed up there? The y-intercept. The y-intercept is what? -10, and therefore my parabola would not be able to be like that. But let's cheat and go like that and say the scale's kind of off and that's actually -10 it's touching it. Okay, now that's possible. All right, did anybody else have something intelligent they wrote down that they knew about this parabola? Yes? Yeah, it's got a triple stretch in there. There's a stretch factor of 3. That means that it should not be the way I wrote it. I wrote it kind of really fat. This should actually be very skinny. Like that, and maybe that's -10 that it's touching at. Okay, it's good enough. Just wanted some general stuff there. Any of you guys ever launched a rocket? A few of you have. It's pretty cool, isn't it? That thing launches, you definitely have just a little moment of like, whew, that's cool. They go really fast. Of course, this is frozen in time here, but when they launch, they go up really fast, and they oftentimes go up so high you almost lose sight of them, and then they drift back down. NASA, of course, encourages people to in this hobby, and so they have this little graph that I picked off their website. Shows that it goes up under power, and then it coasts for a while. They actually go vertical for a while, and that would be when it's reaching its height, its zenith. It starts with a V, vertex, and then at that point, once the rocket has had enough time to have paused, then it hits the other part of the little cartridge that you put in the bottom of the thing is shaped like this, and the bottom part of it is the part that makes you blast off, and once it burns through that, there's like a little lull, and then the other end of it like explodes, and that causes the little fire to go up this direction, a little bit of smoke, and it pops the end off of it. Here's the little cap coming off, and then that has a parachute that pops out, and then the thing drifts back down to Earth. Otherwise, if it didn't have a parachute on it, then it would just turn around and start heading back towards the Earth. And terminal velocity, the fastest it would go without being powered, would be 200 miles an hour. So if you actually made one of these things without a parachute on the top, you'd be making a missile that would be then coming down at 200 miles an hour and could kill somebody, literally. So anyway, do you see how this is generally a parabola? It's making a parabola. And the parabola has a vertex, which is the highest that it ever went. It also has zeros, down here. And you could model it with a parabola. So here is the data. See on the graph, see it's sort of parabolic. It's missing some of the pieces because it only took data every 2 seconds. This little rocket was fitted, with a a little altimeter, I think it's called, and it could record how high it was going every few seconds. And so at second 1, it was at 300 feet. At second 3, it was at 600 feet. At second 9, it was at second 5, it was at 900 feet. 7, and then all of a sudden, second 9 is missing. Could you see in the real world where all of a sudden you might have a glitch in your data? It might not record one of the times that it was supposed to. That happens. Yeah, or maybe the time it recorded is messed up because all of a sudden it says it's 0 at 9 seconds and you just throw it out because that can't be possible. So our data sometimes has gaps in it, and that's okay. If we enter this data into the calculator can tell us a line that matches it. And it'll tell you the equation for it. Just like it did when we did linear regression. Do you remember doing linreg? Those linear regressions were when they were straight lines. Well, this is the same idea except it's curved. So now, let's put this data into the calculator. Put it under stat. So I'm going to go to stat and edit. And you probably have data on your list 1 and list 2. If you want to clear them out, just hit delete, 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 delete. Don't try to hit the clear because a lot of times people will dump their whole list. Their whole list will disappear and they won't have an L1 anymore, which is kind of a pain. Delete, 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 delete. Just get your data out of there and then put in new data. And the first one's a 1. So I just go down the first column. 1, 3, 5, 7. There's no 9. Don't even have a placeholder. And then there's an 11, 13, and 15. And then arrow over and get your other data in there. 300, 600, 900, etc. Okay. Now, I hear most of the calculators have stopped tapping, so I'm guessing you got your data in there. Now you go to Stat, arrow over to Calculate, and find QuadReg. And there is a question behind me. Yes, sir. Oh, I had one number wrong. Thank you. Stat. Now, I honestly did not do that on purpose, but I was going to mention that we have probably 70 keystrokes in a row there. Wouldn't it be really easy to be on the test and typing in your data and do what I just did? Type one number wrong and there's a number that's going to screw up my whole answer, isn't it? Yeah. So be careful. Double check your list. And you guys said I messed one up. Which one? Oh, I have 111 in there, yeah. Instead of 11. That would be totally goon my whole answer. Just because I have a double hit on the button. Okay. So then I go to Stat, Calculate, QuadReg, and then all you got to do is know what this thing is. If you hit enter one more time, I just did cubic. Bah. Stat, Calculate. I should just hit the number. I try to arrow down so people can see where I'm going, but it's probably easier. I'll just hit the 5 for QuadReg. There. Okay. Hit enter one more time. And there it is. There's my ax squared plus bx plus c, and there's my a, there's my b, there's my c. Now, honestly, how many of you looked at this and you had clicked one number wrong yourself? Because your number isn't exactly the same as mine. All right. I'm just gonna say that last hour we had several people have a mistake in their list if they checked their answer and it wasn't quite the same, and it was because they typed something wrong. So it'll happen if you're not careful. All right. So now that is the equation. Would you write exactly that? No, you wouldn't. You would write it out with y equals, and then instead of a, you would write negative 16.42, and then you say x squared. What I'm trying to say is, don't just copy exactly what you see on the screen. Write it out in an equation. And your first number you put there with an x squared, and your second number that they give you, you put there with an x, and the third number you put there. Okay? Now, what could you do with that? What you could do with that is tell how high the rocket was at any point. Like, for instance, the missing point. You remember how it was supposed to be 9, but we never got data for that? Now we can go back and see what that should have been at 9. What I want you to do is type this thing into your calculator. You'll have to put your numbers into the spots that have empty spots here. Maybe you can tell me what those numbers were. What was A again? Negative what? 16? And let's just call it 16. On the real test, you should not round it. You should give your answers with the decimals. But we'll just round because it'll be a lot faster. And then it's got to be x squared. Why am I putting an empty spot squared? Because we're going to figure out the time 9. So we're going to put 9 in for x. Do you see what I'm saying? Instead of x, we're putting 9. And now the next number was like 35, or was that the last number? What's the next number? 255? Does it round to 256? All right. And if you're off a teeny bit because of that, no big deal. And then the last part is 35, was it? Or is it around to 36 or what? 36. Okay. All you got to do is type that in your calculator. Again, I had like 7, 8 people last hour that got it wrong at this point because they just typed one little thing wrong. They had one little empty parenthesis they didn't close. That kind of stuff. So be careful. And now tell me, what was the missing data? How high was it at 9 seconds? That's missing here. What do you get? 1008? Anybody verify that? Got about the same thing? Okay, good. All right. So you could also figure out at any time, like how about this? This is an easy one. Looking at this equation, if I made x 0, what does that mean about the problem? Where is x going to be 0? When was that? Is that halfway through, or when was x equals 0? The start, at the very start. And if you put in x equals 0, these will become gone. 0 times anything is 0, and the answer would be 36. That's also known as the y-intercept, right? So that means what about my rocket? It started 36 feet off the ground. Is that possible? Yes, it is. What if you are launching it from on top of a building that's 35 feet tall? Okay. And it didn't, but look at my data. See, it didn't, it sort of looks like it started up here off the ground, doesn't it? And that's what my, I don't, all I know is my data. I have to assume that the calculator is probably pretty smart on that. It probably knows that it was off the ground when it started. So it's almost like a CSI kind of a thing. You can track back and figure out like what happened. We could figure out when it hit the ground. That spot right there. So what would I do? I would, instead of I could just like put in a 16 seconds, see if it hit the ground yet kind of thing. 17 seconds, see if it hit the ground yet, but that's kind of a weak way to do it. What are those things called down here? The zeros. How can I find the zeros? I could graph the thing and then hit the second, calculate the zeros. That would work. All right. Yes, you could set y equal to 0 and solve for it too, that algebraically. But on the calculator, since you're using the calculator, it'd probably be easier to do the graph, find where it touches. Okay, here's one more. This one's only hitch, it's the same kind of a problem, is that it doesn't want you to enter the data exactly as you see it. Do you get why you might say that they're going to use a 0 to be 1990? That'll mean it'll be easier to type these in, right? Because instead of 1994, what are you actually going to put in? 4 goes with 35. And 1995 will be 5. Goes with 750, etc. Now one more thing I want to change. I goofed up my numbers here. I meant this to be 2001. 2001. Would you please use this data? Again, change the numbers so they're like this and put in that list into your calculator right now from beginning to end and tell me the equation you'd get for your quadratic regression. Just want to see if you can do this by yourself without me telling you what to click. When it's all said and done, your answer should look like this. Except A, B, and C are numbers that they'll tell you. Mr. W, what'd you get? Okay, I believe you. Do you totally confident you know how to do this, though? All right, good. You want to hit me with, or did you get done? Okay, who's done? All right, give me a number, blue shirt. I want to see your name on the recording. Negative 74.3. Can anybody verify that for Mr. M? All right, good. How about the B term? Keep going. 1082. Okay. And the next one, the C term? Negative 2956. All right. Now, does something seem squirrely about that to you? The y-intercept. What does that mean about my data? Yeah. How on earth are you going to start off with negative 3,000 DVD sales? Okay, so that means basically that my data probably wasn't very good. Know why? I totally made these up. I just made up these numbers. I didn't actually look up DVD sales for those years. And so it's probably either A, it's not actually quadratic data. Maybe it's linear data. It does go up and come back down again, but it's just made up numbers, and so therefore this is kind of busting me on that, and it's telling me, then your answer's going to be all goofy. All right, so we've got numbers that are actually real numbers for your test, but okay. Still, the conclusion we can draw is that something's wrong with the data. Either that, or maybe it's not going to fit a quadratic model. Maybe it needs a cubic model, or maybe it needs something else. There is cubic regression, true. Okay. How many feel comfortable with how to put that into the calculator? Okay, good. So then we have mastered another kind of problem you'll need for tomorrow. Or, sorry, the next day, Friday. Write an equation like this, except it does this. So you're going to write me an equation like this one right here, except that will make it move right 8, 3 times wider, and half as tall. Don't start with this one. I'm just trying to say it'll look like this one when it's done. So write me an equation that will do those things in that order. I could say y equals instead of f of x. It's pretty much the same thing. The number out in front, which one would that be? The half as tall or the 3 times wider? The half as tall. On the inside, I need it to move right 8, so I can go like this. And then up 2, that'll be like this. It's not a parabola yet, so now it is. And then the 3 times wider, this is a really common mistake. People put like a 3 there. That would not be 3 times wider. That would be 1/3 as wide, right? To make it 3 times wider, I'd have to put a 1/3 in there. You get that? Now, what if I had parentheses? If I do parentheses like this, would I really do the right 8 first? No, I wouldn't. Because if I had parentheses, I'd be forced to not do them first and do that first. So then I do not want those parentheses in there. There. Now, normally you do multiply before subtract, so we do the subtract first because we're counterintuitive on the inside. So now I've got it right. Okay? All right. That's the kind of problem we've done before. Why is vertex form so nice? Because it tells me the vertex. 5, 6. Right? Right? Yes. So then how about the axis of symmetry? Is that related to that? Yep. If this is the parabola that goes with this, then where's the axis of symmetry? Right down there. And if you say, if you say 5, I will cry, because you should say x equals 5 is the axis of symmetry. You have to have the x equals, otherwise it is not a line. 5 is a thing. It's not, it's a count. It's not anything on a graph. All right. Completing the square. Remember those? Try this one. Complete the square. That means the plus box, minus box thing. They could also have said, find the vertex. And you'd be completing the square. Because on the calc, some of you might be thinking, well, I just graph it and find the vertex that way. Well, you won't be able to use a calculator on this part of the test. It's another one of those 2-part tests. You can use the calculator on the linear regression stuff we just did, but you won't be able to use a calculator on anything else. And a quote from Mrs. Richens last night when she was looking over the test, she was like, they shouldn't have any problem without the calculators as long as they can, and I'm going to change the numbers here, as long as they can like take 100 divided by 4, they'll be fine. Okay, so if you can do simple math, it's not like you won't miss the calculator. It's no big deal. Like for instance, now you have to be able to say 7 goes into 28 how many times, otherwise if you can't figure that out, yeah, you'll have problems. Okay, so first step, plus box, minus box. Second step, factor out this first thing. 7 comes out, x squared plus 4x. Don't mess with the box. But do remember the most commonly forgotten thing. JJ, what would it be? You got it. Got to put a 7 there. Next thing, half and square half of 4 is 2. 2 squared is 4. 4. Final answer, y equals 7, parentheses. And there could be 2 sets of parentheses that are identical. I'm just going to put them together right off the bat. X plus 2, quantity squared. And then negative 28 plus 4 is negative 24. Raise your hand if you had that one right. Okay, good. So you have completed the square. Why did we do that? Because now we have the what? The vertex. And the vertex is negative 2, negative 24. And if I needed to graph it, I'd know I'd start there. Does this have a stretch factor on it? Oh yeah, 7 times normal. So I go over 1 and up, what? 7. Okay. Point slope. Here's 2 points. Use that y minus y sub 1 equals m times x minus x sub 1. Use that whole thing. Figure out its slope first. I'm going to pause while you crank that one out. Okay, we have negative 11 minus, whoa, that's weird. Sorry about that. Negative 11 minus the 1 and the 2 minus the negative 5. So it really stretches you on the negatives. Handling those, that turns out to be negative 12 over positive 7. So negative 12 sevenths is your, what's that called? Slope. So y minus y sub 1, I got to pick a point. I'm going to pick this one. Doesn't really matter. Could use either one. Y minus the y of it is 1 equals m, which is this, times x minus x sub 1. X minus, and the x sub 1 is negative 5. I have 2 negatives. I should make it positive. Raise your hand if you had the right answer. Good. Do I have to solve that thing for y? No. You're going to leave it just like that. Don't want you to solve it for y. Reason? Because I'll give you an example that they give me that's a pretty good one from calc. The reason they don't want you to go farther than you have to is that if you go farther and you do it wrong, then you get it marked wrong. This happens on the AP test too. A lot of you are going to go on to AP Calc next year. And if you've got an answer that's right, and you go on and try to simplify it farther, and you screw something up, then it's marked wrong. So you can end up, really hurting your score by going too far. You're not supposed to simplify things any farther than you have to, because if you try to go too far, you'll get it marked wrong. So don't mess with this. Leave it alone. Because if you made a mistake after that, I'd mark it wrong. Okay, next thing. This is just like y minus y sub 1 equals m times x minus x sub 1, except here's the new formula you need to memorize. Y equals a times x minus, do you remember? H plus, all right, write it down, memorize it. You have to know this formula, because then you can do quadratics, just like you did linears, straight lines. Now you can do curved lines. You have to have the vertex and one other point. Just like before we had to have 2 points, except we can't just take any old 2 points. We need the most special point of them all, the vertex, and then any other point. Now where do they go? Well, I think you know where the vertex goes. It goes the same place it always has gone. Those 2 spots are where the vertex goes. So where does the other point go? Here and here. Okay? Try it. Solve for A. A is a nice round number if you do it right. It's not always a nice round number, but in this case, I'll tell you, if you put in the right numbers and you solve it right, get a nice round number answer. So I'm going to put them in there. The vertex was 5 and negative 2. The point on the parabola was 6 for the x, and the y was 8. Now if I write out exactly what I have 8 equals a times 6 minus 5 squared minus 2. And that means 8 equals a times 1 minus 2. And that's 8 times 1 is just a. So I add 2 to both sides, I get 10. Raise your hand if you had 10. Okay, good. Then what's the answer? 10? No. A lot of people get this wrong because they stop right here. The question will be, write me the equation for the quadratic. Well, that's not an equation for a quadratic. That's just what the stretch factor is. So now I can write y equals, and use that stretch factor, 10, and now do vertex form. And the vertex is negative 5 goes here, because it's 5 comma negative 2. And there's my answer. Oop, not that. There's my answer. You get that? Just all you did at the beginning was solve for a. You were figuring out this part. And now you go back and just write vertex form and throw a 10 in front of it. Okay? All right, you get a chance to practice that again on the worksheet. But you got to have this memorized. I'm going to rewind. Go back in time here. That blue part right there, got to know that, otherwise you won't be able to solve these. And you got to know what goes where. That's the vertex. That's any other point. Okay. Use the quadratic general form like you used point slope form. Well, here's the same exact problem, except I didn't give you 2 points. I gave you 5 dots. You figure out which dots to use and figure out the answer. The answer is, what's the equation? And if you can do it without that process, you probably can. You can just write me the answer for the vertex form. Cool. Just make sure you have the a figured out. All that other thing does is tell you what the a is, but I can look at this and figure out what a is. So you write me the equation if you can. For those of you doing it this way, I'm going to do it really fast. Y equals a, x minus h plus k, and this would be, I'm going to pick, well, I have to pick that for the vertex, and I'm going to pick this for my other point. I could have picked anything, but I'm going to pick negative 3 comma 0. And then I'm going to put them in here. So y would be 0 equals a, I don't know. My x of my point is, this point right here is negative 3 minus the vertex thing, which is, it would normally be a negative 4, and so it makes sense that it would be a positive 4 in here. And then plus the k would be, is the negative 2. And then I would have, that's a 1, so 1a, so add 2 to both sides. A is 2. There. Wouldn't it have been a lot easier to just look at it and see that a was 2? Yeah, but if you can't just see it, this process tells you that. All right, I can look at it though and see a is 2 because I know it's stretched. It's not the normal parabola where you go over 1 and up 1. I go over 1 and I have to go up 2, and I know it's a 2. Yay. And then I'm going to put in x minus, and then the vertex is negative 4, negative 2. So I need a positive 4 there, and a minus 2. Final answer. Raise your hand if you're comfortable with this kind. All right, good. If you're not, do more practice on it tonight. The test isn't till tomorrow. All right. There's a little bit more. Let me see here. No, that's an old one. Well, that's just some extra slides I have in there and I do not need. So we've covered the stuff that you need to know. So now we have some time left, about 15, 20 minutes. I have a worksheet for you that you can do for practice. The answers have been posted now for the book, and I think these answers are going to be posted tonight, so you could do lots of answer checking if you wanted to, which is handy because tomorrow we're going to grade a bunch of things in class. I haven't put anything in a grade book for a while. I didn't want to interrupt what I was trying to teach you with that, but tomorrow I have nothing to teach you, so we are going to be grading stuff tomorrow.